Hey, so welcome. We're here in Denver, Colorado with doctors Sanford and Gop. We've got an event tonight in partnership with Data IQ to explore the deep end of the pool, large language models, generative AI, and what most people think of as ChatGPT, and what's real, what's not real, what's it really mean to our business customers, right? But before we jump into that topic, let's rewind the tape a couple weeks. We were at Snowflake Summit. It was super cool to hear Jensen Huang talk about NVIDIA and generative AI on top of Snowflake's platform. That's what I took away. That was like kind of the big news to me, but I'm the dummy of the three of us. And so I think there's actually some more compelling stuff probably around that, below that, and above that, that might actually be more relevant to the immediate future where LLMs maybe one day are the difference maker. But what do you guys think?
Yes. So the announcement with the NVIDIA partnership came in conjunction with Snowflake having the ability to deploy containers inside of their environments. And one of the things that's really neat about that is that if you look at the potential for models, LLM models being integrated with the data warehouse, and of course Snowflake has become the de facto data warehouse. Now you have the ability to have large language models trained on your company's data specific to your organization. And so, if you look at the multitude of variables inside of a data warehouse about sales or prices, utilizing this firm specific knowledge, we're actually going to be able to have a much faster, much better handle on the BI inside of a company. I think this announcement, of course, there's some tactical things about this announcement, being that you can use NVIDIA GPUs kind of on demand inside of your Snowflake data warehouse using Snowflake credits is really interesting. But the art of the possible of having a data warehouse and a BI tool trained to your data and the behavior of your analysts is the part I thought was so neat about it. In addition to a couple LLM announcements around generative SQL and that kind of stuff.
I mean, I want to back up a couple topics. So when I try to explain machine learning in my own kind of basic understanding, I always think of X-rays. So if you show a machine learning algorithm, call it 10,000 X-rays of healthy lungs, and then 10,000 X-rays of lungs with cancer, immediately, or something close to that, it can actually start to look at X-rays and see cancer where doctors, even the best doctors, don't necessarily see it. So we don't know how it does it necessarily. We don't know what it's actually picking up, but it's creating its own rules for interpreting X-rays that are more advanced than humans can do. And so that's kind of the magic of machine learning. As much as Elon Musk might tell us to be afraid a little bit, it is actually pretty fascinating. Marty, what's your take on? Help us dig a little bit deeper on kind of generative AI as a topic, and what's an LLM?
So an LLM stands for large language model, and it's models that are trained on just gigantic corpuses of text. ChatGPT used the internet, so it just took all the text from the internet and used that. And what you're looking for is the relationship between words, context, all that. And then an LLM model uses that as the back end, and you ask it questions like a chatbot. And the thing that allowing us to access GPUs does is now we can take the LLMs that are out there. We can basically say we only want to use the first 80% of it, and we can feed it our own custom data to our specific domain and finish the training on it. And if you kind of think about it, it's like you learned how to speak English, but maybe you move to an area where the dialect's a little different. The language is still the same. You just have to pick up some of the dialect and those kind of nuances. That's what it allows you to do. GPUs are important because they give you more processing power and let you do that training in a reasonable amount of time.
So I think to me the fun example is if I took all of Stephen King's novels and I gave them to into a corpus and let a AI model study them, I could then say, hey, write me a dirty limerick in the style of Stephen King.
Yep,
And
exactly.
do it, right? And that's like it's a really dumb, fun example, which don't do it at home because you might get in trouble. But like,
And
Well,
copyright.
so your example, I liked your example of a tumor, not a tumor, which
Yeah.
is what you were getting after,
Yeah.
right? So you take historically we've used machine learning to use labeled images about say lung cancer, to sort of lung cancer, not lung cancer, and many different versions of that
Yeah.
to assess when you see a new picture, is this likely cancer or not? What generative AI is doing is basically flipping the question back on itself and saying, draw me a picture of lung cancer,
right.
right? And it's using all the pictures from before,
Yeah.
and it may be like draw me what lung cancer would look like
Yeah.
in this type of individual, where we don't really have many pictures of what that individual would look like, right? Like draw me lung cancer, in a 58-year-old woman that has been smoking for 22 years and happens to live in this part of the world.
That's
and so
right.
the concept of generative AI has really kind of been there, but it's just flipping the question from categorization back into make me a picture or make me a description or make me a story.
Yep.
That's pretty cool.
And so in some sense it's a good, there's been a good publicist in charge of the GPT world, but it also opens up some pretty interesting possibilities.
Yeah.
And the word generative, I think you have to be careful because it's not generating brand new things. It's really combining what's already there in a way that may not exist in our world. Like the example, there may not be a 58-year-old smoker from Belarus who has cancer, but we know enough about that kind of a person and what cancer looks like. We want to make an example of it. So we've melded 4 different things together. If you'd say, generate me an alien from Mars that has cancer, that doesn't, there's nothing to base it on.
Right, exactly.
So you literally, you have to make up something.
And then you mentioned GPUs, right? And so just like we think about how the iPhone has changed the world in terms of processors and batteries and everything else that kind of ripples out in these concentric circles and impacts a number of different places in our life, like GPUs started somewhere and now they're impacting our lives in other places.
Well, they started in the gaming world,
Right.
which is the funny thing, because gamers wanted graphics that rendered quickly, smoothly. Well, graphics are just giant matrices of numbers. And all these models that we're talking about also use lots of numbers in rows and columns in matrices. So it was a natural blending of the technology to say, hey, we can use these GPUs to solve these problems really fast. And that's what they're built for.
So as much as moms and dads hate Call of Duty, Call of Duty's been responsible for
It's
innovation somewhere.
well, the NVIDIA conferences are a hoot because you got the gamers and the computer science guys there. And a lot of times they overlap, but other times they don't. And you have really strong academics who, wouldn't be caught dead playing a game, but they want the same thing. They want computers that can do math really fast.
So, and there's tremendous scarcity right now, and you see this in the way that AMD and NVIDIA share prices have jumped in the last 4 or 5, 6 months. Yeah. There's tremendous scarcity in enough of these processing units. The Snowflake announcement is another example of getting another avenue that you can rent out these GPUs because the main cloud providers are sort of maxed out. Marty's got a GPU workstation. Those are popular tools these days where many laptops now will have their own GPUs in it.
like Apple's sells a standalone GPU. You can
Yeah,
play
the latest Mac has essentially a GPU that I think it's the M2 processor is a GPU processor.
But why this is important is, if there's a future in which we all will have our own language model, our own email generator, but we want it to sound and act like us, and we want and in order to do that, it has to train on our data, and of course, our data live in certain places, right? So I've got, I write Gmail emails that look a certain way, and my text messages look a certain way, and Spectrum owns some of that, and Gmail owns some of that, and where is that training going to happen, and how do I get all that data into one place? So there's going to need to be a lot of variety in where I can train one of these LLMs, so that I can have a Ken specific LLM that writes a a response that sounds like me.
Yeah. So what are the conversation, we can pretend we know the conversation between Jensen and Frank as they sat down and said, hey, let's think about this partnership. What are the natural benefits to Snowflake and to NVIDIA in that relationship?
Yeah, so Snowflake is one of the reasons why Snowflake has been so successful is it's a very easy product to buy. And with the way that Snowflake credits are sold, and the need for, again, more processing power at the BI level, I could easily, there's a natural symbiosis around having the ability to rent GPUs next to Snowflake. That it may be under the control of data scientists, less. Whereas if I needed to justify GPU usage on, say, bare metal AWS, I'm going to have to go to my IT department and find resources. But I might have my own budget of Snowflake credits that I can use at my own disposal.
Right. So rather than building your own GPU or having your own physical GPU on a PC or laptop, which has obviously physical constraints, but also has probably performance constraints, Snowflake offers a much less constrained platform, and it's in the cloud, so you can connect to it and model it, and 5 people can access it. It's a centralized resource.
I want to do something on my laptop. I'm the IT department.
Yeah.
I've got to figure out how to do it, and it's not trivial because it's a different architecture. With it on Snowflake, I just literally go to the store and say, I want one of those and use it. I got to pay for it, but that's what it's there for. Renting GPUs, unless you are going to use your personal one 100% of the time, all the time, renting it is probably the smartest way to do it because you can scale it if you need a real big one or you need a real small one. And you may only need it for an hour. Yeah. It's much cheaper.
Yeah, I'm sure you guys have better numbers, but I was reading about ChatGPT, and I read 2 different articles. One estimated that they were spending $1 million on cloud resources a day. Another one I read was like $3 million a day on cloud resources when they open up ChatGPT to the world. Now I know they're starting to throttle it back, and there's a great Stanford University article about that as well. But it's like you see, like it's not trivial or inexpensive. Again, we're also talking about tens of thousands of people using it at the same time, I imagine, right?
Yep.
Yeah. Well, compute costs money. Retraining costs money. Now, prediction doesn't usually cost much money, right? Those are relatively easy. Once a model is created, scoring it or doing the inference is relatively small. But if you have to retrain, it can become very expensive.
It's like the plumber that walks onto the battleship because it's broken down, and he hits a particular spot on the engine with his hammer once and it fixes it, and he gives him a $2,000 bill for it, and you're not paying for what he did, you're paying for all the training that got him there, right? It's I think the same way, it's not the questions we're asking it down the road, it's the investment up front to make sure it understands the domain of knowledge, right?
Yeah.
Exactly.
And we'll see that in as every we were just at a OneStream conference, right? And OneStream's very good at financial planning, reconciliation, forecasting, that kind of thing. They'll have their own LLMs that work really well for those types of problems. Yeah. Every software company that has a domain specific knowledge will have a specific LLM that works well for them. It's going to take time, but when they do, expect them to earn extraordinary returns. They're not going to just charge the cost of the compute in order to make that prediction. It's going to be the cost of that compute plus a tremendous amount of knowledge associated with it, right? And it's the parable of the mechanic that you're talking about, right?
Yeah, and I think
they all become data companies because it's really their data that they've collected and curated and maintained over the years of their existence. That is their true asset, not necessarily the tool you use to interact with it. It's the data behind it. And that's what's going to really change in a lot of this area is those. I mean, that's what Facebook is. They have a lot of data on people. It's not a cool interface that they're selling. It's that data access to that data for you as an advertiser or for you as a politician or whatever.
Yeah. At Archetype, we've had this Venn diagram of a highly skilled and talented team of people that really understand the office of the CFO and accounting and closing the books and budgeting and planning and forecasting. And the other side, we've got amazingly talented group of people who understand the stuff we just talked about. And what I'm excited about is this intersection, right? Whether you call it like XP&A, like financial planning analysis, or anything planning and analysis, it's like, how do we start using machine learning or any general like data science capability to start to help forecast more accurately? And to me, like that's the low hanging fruit where there's a great like finance value creation by virtue of leveraging, whether it's a large language model or even simpler time series calculations. Like that's where the low hanging fruit lies. Building $1 billion company, building their own LLM around their go to market, maybe a longer. Any kind of closing thoughts on that?
I mean, I like if you take an archetypes structure where we have like the team that Marty and I sit on, which is kind of horizontal technologies around various parts of the stack, and then the side of the business that's the OneStream side of the business, where it's an opinion on top of some data. And you see this across many industries where there needs to be an intermediate layer between the source transactional system and then the final reports, right? Because Salesforce, for instance, is so flexible that you end up with just a scattered bunch of junk, right? And then you have like a CRM or a CPM type system which puts opinion on that junk, right? And then in our world, we can build darn near anything, right? Just based on us injecting our opinion. But I guess what I'm getting at is that across industries, opinionated software tends to win, right? And so if you create an opinion and this metadata layer that makes sense specific to certain industries, you're going to be able to create an advantage which will persist.
Yeah, exactly.
Right?
Marty, closing thoughts?
Well, and just to piggyback on what Ken said, using the expertise of the people who know the data inside out to help you with setting the model up properly. You can't discount that at all.
Right.
A lot of data science focuses so much on, I'm just going to let the data talk for itself. But data without context doesn't give you that information. I can't tell you how many projects I've worked on where people say, don't trust this data after this point because this event happened, which may not be evident in the data, but the person who knows the data knows that. Yeah. The same thing with all the finance people. They know what matters in that world. They just need help with some of the math to do the prediction. Yeah. And that's where the two have to work together. So the data expert doesn't have to be a data scientist, but has to be involved in the data science.
The simple example is like you can't use time series to predict what's going to happen around an interest rate change by the Fed because it's hard to predict the Fed and how it's like this is the human element, right? You can almost predict everything else around it, but then you have to kind of account for some lag in that rate change. But
or the personality of who's in charge of the Fed, who's the president, who's the all the personalities involved. I mean, it's kind of you kind of have to be the Jack Ryan of of the Fed, and really study that and know what these people do and what their motivations are, and then you can say, I think this prediction is going to happen. All right, data scientist, help me figure out how to use this in a smart way.
Yeah. So we started 3 or 4 or 5 different threads that I think are fascinating. I'd love to be here all day talking about it, but keep your eyes out for more content on this topic. We'll talk more about Data Haiku tonight, and we'll pick up where we left off. Thanks for your time and attention.